All right. Good evening, everyone. Let's start with today's webinar. I welcome every attendees and I welcome to all those who would be joining in late. Now, today's webinar is one of the most key and I would say difficult topic rated amongst top difficult topic, which is inequalities. So my first recommendation and request to all of you is that you have to definitely go through this recording at least twice or thrice so that you could have the understanding of all those key, or let's say the fundamental properties, which is must that every GMAT test taker should know for solving the inequalities based, maybe like be it a PS based questions or DS based question. And this is not a topic that one can command over the night. So whatever you can make a note of, definitely you should in today's webinar. I'll try my best to pace up properly, but you have to definitely look to this recordings at least twice or thrice. So without wasting much of the time, and once you see your this particular recording in future, if you have any sort of questions related to a question or a topic, please just try sending us an email to discuss more about it. uh, let's go with the agenda for the today. I'll be talking about the math revolution and a GMAT math overview in a short. Major concept would be of inequalities, and then how the conventional approach versus math revolution approach is balanced, and decided which one we should go for. Talking about math revolution, as I have been telling that we have been established in 2001 in South Korea, and it's been more than 190 plus countries where our site visitors comes through, and 130 plus country we have the members from. Over 41,000 students have been trained by the experts from Math Revolution, and 90% plus students have scored Q49. That is our major achievement. If we talk about the goal of the GMAT math, is the same as what every GMAT test taker has. No one wants to be just satisfying a score of Q45 or less. So what is it that can make your score raise to 49 or 50? That is wherein we have come up with our unique approaches, which is variable approach for DS. This is something which I always talk, and the IV approach for PS. Now, the solutions that we post onto GMAT Club, which is one of the bland resource for the GMAT preparation, there you will see a lot of questions where the solution is being posted by the help of variable and IV approach. So you can often check those onto the GMAT Club as well, or you can often visit to www.mathrevolution.com, and once you scroll, you can witness the difference between the conventional and the variable approach for two of the questions which is there on the website. Let's talk about the person who is behind this complete approach. So we proudly say, Max is a person who has not even who has not only invested his time, but efforts, patience, and this is all done for the students, because he has come across this challenge that there are a lot of things which a student often forgets to consider during the DS question, and therein where they lose on accuracy and time. So he is the founder of the Math Revolution. He is the mastermind behind the world's first unique approach, which is variable approach to solve the DS question. He himself has taken GMAT almost 27 times and have solved 100,000 plus questions to come up with such kind of unique approaches. This is the major key areas, you could say the major pillars on which Math Revolution stands. Uniqueness, because it's a world's first approach, be it a variable or a IV. It's irrelevance to the person whether they are from math background or a non-math background. It's easy driven, easy to understand, easy to apply, easy to learn approaches. Quickness, yes, you would be able to, if you master it along with the traps and some exceptions, you would definitely do well into your exam, and you will still have at least 10 minutes of time left out for you, and you will complete all the questions before that. And accuracy, again, that is what matters a lot in the exams like GMAT. This is one of the key slide. What are the strategies for 50-51? I've been talking to a lot of students over the period of 2 months, as we have started one-on-one free consultation. And I agree, I believe that most of my attendees today in this webinar may had a chance to talk to me. So I always talk about, like, try always looking for some of the fundamentals and plus some approaches, some quick tips and techniques, because GMAT is a test bounded exam. It's a time bounded exam. If I give you one question for a whole day, you would easily make it. But if I give you the same sort of question with a higher level of difficulty in like a minute, you may not be able to even get to know that what is my first step to solve that particular solution, especially in maybe in the geometry or inequalities or absolute values. And yes, again in the factorials and prime numbers. So, with the conventional approach, I would say it's not that difficult to score 50, 51. But again, the amount of students that are able to score is less. So if you could manage to have something for yourself, like variable approach for DS, IV approach for PS, and then you have a lot of logics because you have learned those concepts and you're confident about applying it because you have practice over it, then most of you will be able to make it 50, 51 very easily. So this is the basic strategy for 50, 51. Now let's start our major webinar without making any late to it. So there are a lot of things that I'll be discussing about the range and everything. So please be focused and don't leave the webinar until we reach to the last slide. So having said that, let's talk about the first fundamental concepts and inequality, which is all about, how do you measure things. So if it says like if A is greater than B and B is greater than C, we could also read it as A is greater than B, which is greater than C. So we can break it into A is greater than B, second B is greater than C, and third A is greater than C. If you are able to do this, I don't disagree that you don't know it, but how many of you actually break it when you see such kind of inequality is the question. So always break it. And if it says A is greater than X and X is greater than B, always combine it. A is greater than X greater than B. So these are the two things which I want to start with. If you see one of the inequality like A greater than B greater than C, break it. If you see the break part, combine it. You will definitely reach out to certain options or the solution quickly. Going with this particular example, 5 is greater than 3, which is greater than 1. So we could break it as 5 greater than 3, 3 is greater than 1, and 5 is greater than 1. Similarly, 7 is greater than 5 and 5 is greater than 1. We can combine it. So that happens to be 7 greater than 1. This was one of the first fundamental concepts. Now let's go with the second fundamental concept of inequality. If you add up or subtract the same number from an existing inequality, it won't affect the sign. So it says if A is greater than B already, and if you're adding up or subtracting X be a number from A, and if you're adding or subtracting the same, so operation has to be same and the number has to be same, then your inequality always remains the same. So that becomes A plus minus X is greater than B plus minus X. So if 8 is greater than 6, if you subtract 8 from both the sides, so our operation is subtraction and our number is 8. So 8 minus 8 is 0 and 6 minus 8 is negative 2. So 0 is greater than negative 2. So these are the basic second fundamental concept. Let's talk about the third fundamental concept in inequality. If A is greater than B and C is greater than D. Now there are two sub inequalities which are involved in here. A is greater than B and C is greater than D. So if you combine A and C, their sum would be greater than B plus D. It says the same. The sum of two larger quantities will be greater than the sum of two smaller quantities. See, right now it would look to you that this is very basic, right? But the major challenge that occurs into inequalities question is which logic has to be applied. Okay, so therein where I'm requesting to go on to this videos at least twice or thrice because you would understand which logic has to be applied. GMAT will not ask you this fundamental concept. They will readily ask you to apply this concept. So just hold on for a while. Once we move to the question, then you would understand how difficult or easy it could be for the application. If you have to go through a particular this particular concept, it says A plus C is greater than B plus D. Now let's try this question. It says X plus Y is greater than 2 and X minus Y is less than 2. Which of the following is true? Now I don't want any one of you to put a numbers or something, thinking about X and Y as a number, because how many possible combinations would you take? So in this scenario, we know that the third fundamental concept says us that if A is greater than B and C is greater than D, then A plus C would be greater than B plus D. Secondly, it also says that A plus minus X would be greater than B plus minus X if A is already greater than B. So our question is X plus Y is greater than 2. But the second part is X minus Y is less than 2. The two inequalities are not same. So what we will do here is we'll make the two inequalities first of all in the similar fashion. So X plus Y is already greater than 2. The second inequality, which is X minus Y is less than 2, will make it 2 is greater than X minus Y. Now we have both the inequalities into the greater fashion. So we will add them up. Once we'll add it, we get X plus Y plus 2 is greater than X minus Y plus 2. 2 being common on both sides and X being common on both sides can be cancelled out. So we are left with Y is greater than minus Y. If you move minus y to the left hand side, we get 2y is greater than 0. Dividing both the sides by 2, we get y is greater than 0. Your answer is done. So you have not applied any single number inputs or plugging values. You're directly solving it through the fundamentals. So over here, the answer goes as C. Let's talk about the fourth fundamental concept in inequality. If a is greater than 0, and if we add a to the both sides, the inequality direction would not change. What does it mean? If a is already greater than 0, and if I add a both the side, it becomes a plus a greater than 0 plus a, or 2a is greater than a. Vice versa, if a was smaller than 0, and if we add a to the both side, again the inequality will not change. So if a equals to 3, that is a is greater than 0, if you're adding a or 3 to both sides, it will still remain the same. So you should always know when the sign of inequality changes and when does it not. This is the major challenge that happens to be the fact. Let's try this question. Now, this is a DS question, and whenever there is a DS question, I always ask the students to apply the variable approach. So now let's see, this is an inequality question, which falls into the key question. So be patient. I'll go very slow on this because there is something unique that I want to show you on this particular question, especially. So don't, put yourself solving this question. Just let's pay attention to this. Question says x, if x is greater than 0, is x is less than y, which is less than z. And we have two conditions to support it. Now we understand the fourth fundamental concept is if a is greater than 0, 2a would be greater than a. If a is less than 0, then 2a is less than a. Now you would be surprised or confused that why are we applying the fourth fundamental concept here? I mean, like, why do we take 2a greater than a? Or why do we have to take 2a less than a? So just hold on and we'll see how do we apply this particular concept to prove it. But look at the conditions. How are they? Condition number one is x is less than 3 times of y, which is less than 5 times of z. See, if it was just x, y, z, there was no question to it, but 3 times y, 5 times z, it's not necessary that, you could get the value for x and y separately. Condition number two says 5x is less than 3y. That doesn't mean x is less than y. And 3y is less than z. That doesn't mean y is less than z. So in this particular situation, when you see such kind of numbers associated to the variables, or they are the coefficient to the variables, you can always apply this particular concept. But now how do we apply it? So the first property of inequality says that if you're multiplying or dividing any inequality by a positive number, the sign will not change. So if a is greater than 0, 2a would be greater than a. If a is less than 0, 2a would be less than a. Now let's talk about this. Let's modify and recheck the original conditions. We need to verify whether x is less than y, which is less than z, if x is greater than 0. Our answers would be yes or no. For if it happens to be a maybe condition, then definitely that particular condition will not be satisfied. Now the concern is, as we're dealing with three variables here, which is x, y, and z, and I have one equation which directly says x is greater than 0, that means I need just two more equation to match up. This is what the beauty of variable approach or concept of variable approach is, that you always try to check the number of variables and conditions into original question stem along with the conditions that will support it. When I need two more conditions, definitely I'm sure that I'll get the condition or the equations from condition number 1 and 2. So my answer should be C. Now, when I know that my answer would be C, I'll not either waste a second of mine and I'll quickly combine both the conditions or both the statement number 1 and 2 together. So once I go ahead and combine those particular conditions, I get it as 5x plus x, 3y plus 3y, and pi z plus z. Inequality sign doesn't change. I get it as 6x is 6x, 6y, and 6z. The condition is still the same, which is 6x is less than 6y, which is less than 6z. And removing 6 gets me to x is less than y, which is less than z, and I get my answer is yes. So this says that this particular combining was unique to give the answer, hence C is the answer. But now this is where I have been always talking about, that there are some exceptions which one has to always master in the variable approach. If it happens to be a key question, then if C seems to be an answer, then hold on for a while and check for A and B also. In this particular situation, inequality question, statistics, geometry, and integers are all key questions. For more information, you could always check the lessons on mathrevolution.com. So if it's a trivial condition, may not be answer. Trivial is something which is looking very easy, may not be the answer. So we will check individually. Let's go and check the condition number 1. It says x is less than 3y, which is less than 5z. If I put x equals to 1, y equals to 2, and z equals to 3, then this particular condition will hold, wherein x would be less than 3y, which is less than 5z. But if I put x equals to 1, y equals to 1, and z equals to 1, because nowhere it said that they cannot be equal, then my condition will not hold. So in this particular situation, x is less than y less than z cannot be answered. So right now, A cannot be answered. So answer could still be C. Now let's go and check the condition number 2, which says 5 times x is less than 3 times y, which is less than z. Now we know that x is greater than 0. If x is greater than 0 and z is greater than 0, definitely 3 times x would be less than 5 times x. And z would be less than 3 times of z. This is wherein the fourth fundamental concept is coming up. If A is greater than 0, then 2A would be greater than A. If A is less than 0, then 2A would be less than A. So in this situation, what are we getting here is, if 3x is less than 5x, and 5x is already less than 3y, that means 3x is less than 3y. And if z is less than 3z, then 3y would be less than 3z also. So my expression has become 3x is less than 3y, which is less than 3z. Removing 3, we get x is less than y, which is less than z. We could answer yes. So my condition number B happens to be the answer. Now see, both C and B were the answers, but as per the definition of the DS question or variable approach, the relationship says that if C happens to be an answer in inequality questions or key question, you need to check for A and B. And this is a 50-51 level question. So such kind of level questions is accessible to students from the lesson XYZ. Or you could also check WXYZ onto our website. Let's go on to the fifth fundamental concept, which says -1 is less than 0 and 0 is less than 1. So I can combine them and write it as -1 is less than 0, which is less than 1. So even if I say -1, so a minus 1, if I add a to all, it becomes a minus 1 less than a plus 0 less than a plus 1, which says a minus 1 is less than a, which is less than a plus 1. This is called as consecutivity. So in this situation, We know this happens, but now how do we will apply it into the question is the major challenge. So you guys have to be good into application of inequality concept. This particular video would be uploaded onto YouTube. You can always refer to it from there. All right, let's going ahead with the fifth fundamental concept. If A is less than B, which of the following is or are true? Now understand, if A is less than B, we need to apply the fifth fundamental concept. And how do we see it? Because our option number 1 and 2 has got plus minus 1 into it, and option number 3 is all about the squares. So when you see such kind of plus minus things into it, they're not asking about A and B, they're asking about A minus 1, B plus 1, or something like that. Then you need to think about the fact that if minus 1 is less than 0 is less than 1, that means A minus 1 is less than A, which is less than A plus 1. So how can I make some consecutivity relation so that I can reach up to an option? So now in this scenario, what we will do is we'll check each option. So if A minus 1 is less than B plus 1, definitely A minus 1 is less than A, and B plus 1 is greater than B. And it also says that A is already less than B. If A is less than B, definitely A is less than B plus 1. And if A is greater than A minus 1, then A minus 1 is less than B plus 1. So in this scenario, what happens is we are already getting the first option to be true enough. The first option is already true enough. If we go with the second option, which says A plus 1 is less than B minus 1. Now see, A plus 1 is already greater than A, and B minus 1 is less than B. And our condition says that A is less than B. So now this A plus 1 and B minus 1, they doesn't hold any relation. They may be equal, they may not be equal. So there is no clear relationship. So option number 2 doesn't hold. Option number 3 is all about the square. So it's much better to plug in the values. If you put A equals to minus 2 and B equals to 1, it becomes 4 is greater than this, which is not true. So only option 1 is true in this particular situation or question. Okay, let's go ahead with the next particular concept, which is the first fundamental concept in inequality. It says that if you multiply or divide any inequality by a positive number, the sign of inequality will not change. So if this is the case, let's see if P is greater than 1 and Q is less than 1. First of all, the inequalities are different. Which of the following must be true? If you see the option, there is P plus Q, P minus 1, Q plus 1. So we have to have the first fundamental concept was to break. Second fundamental concept was to add up something to the existing inequality. And then we apply the first property of inequality. Now pay attention to this part. Let's try first. Option number 1 says P is greater than Q. Now if P is greater than 1 and Q is less than 1, definitely P is greater than 1, which is greater than Q. So if we combine this, we get P is greater than Q. First is true. Option number 2 says P minus 1, and on the other side it says Q plus 1. So if I already have P is greater than Q, if I subtract 1 from each side, I get P minus 1 is greater than 1 minus 1, which is equals to 0. For Q less than 1, if I add up 1 on the both sides, see, because I have P is greater than 1, how will I make P minus 1 out of it? By subtracting 1 from both the sides. So that makes it P minus 1 is greater than 0. The second inequality is Q is less than 1. So if I add up 1 on both the side, it becomes Q plus 1 is less than 2. Now, if P is equals to 2 and Q is equals to 0, this both happens to be true. So this is not supporting at all, and it cannot be true. Just because P minus 1 is greater than 0 and Q plus 1 is less than 2, that doesn't mean that this can be greater. So this does not hold. If we talk about the third part, where it says P plus Q is greater than 0, if P is 2, which is greater than 1, and if Q is minus 5, which is less than 1, p plus q that is equals to 2 minus 5 is equals to minus 3 less than 0. But we, so that makes p plus q is less than 0, but that is not the true, because option given is p plus q is greater than 0. So only one option, that is the first option, remains as it is. So the more you come out onto the fundamental property application, the more the quick it would be. Otherwise, if you fall always for plugging in number, it would be very difficult for you to take into consideration. And there are often seen, or it is often noticed that, a student often uh, take either the unwanted numbers maybe, or either they end up not taking the numbers, which can definitely make the difference to the inequalities checking. Second fundamental. So this says if you divide or multiply an inequality by a negative number, the sign will change. Now, this is one of the most important and confusing property. So whenever we talk about this property, let's talk about this. If x is less than 0, so that means x is negative. I repeat, x is negative. Is y over x is greater than 1? With the conditions, say we have two conditions. So in simple, if you're multiplying any particular inequality by a negative number, or we are dividing it, the sign will change. Let's modify and recheck the original condition. It says y over x is greater than 1. So if I just modify this particular first step, it says y over x is greater than 1. Now let's multiply both the sides by x. Once I multiply both the side by x, on the left hand side x gets cancelled, on the right hand side 1 gets multiplied to x, and my sign changes to less than. Now before you get confused, let me tell you, then when I'm multiplying, when I say that I'm multiplying y over x, which is greater than 1 by x, x is negative because it was less than 0. So don't get confused that where that minus sign is, because this expression already says the same thing. So y is less than x. So we are only looking, is y less than x or not? This is our question. So is y less than x? Condition number 1 says the same thing. You don't have to solve this in total. If you simply modify, and you will get 85% or plus times this opportunity to modify the inequalities and get to the one of the options. Let's check out the condition number 2, which says y is less than 0. Y less than 0 doesn't guarantee that x, y over x would be greater than 1. So there's no clear relationship between x and y. So condition number 1 alone is sufficient. Now let's talk about simplifying the higher degree inequalities. Now this is one of the most important rules, so please pay attention to this. It says only odd exponent remain. So if there happens to be inequality on one side, and which is on the other side is 0, like in example here, a cube is less than 0. You should always now get it as a less than 0, because you can divide both the side by a square, because a square won't make much effect. Cube always makes, odd powers always make effect on negatives and positive, even powers doesn't. So a cube less than 0, that means from today it is a less than 0. That means only the odd exponent remains. Cram this rule, I will say. This will be most applicable rule. If there happens to be an odd exponent, if there is an exponential inequalities, odd exponent remains. Let's talk about the second one. Its squares are very important. So, doesn't matter it's a numerator or denominator, you can often ignore the square and even exponents. Like in this example, a cube b square, that is a less than 0. That's it. B square won't make much difference. You can divide both the side by b square. Your expression becomes a cube is less than 0. A cube is less than 0. We apply the first rule, which is odd exponent remains. So that is a less than 0. Let's try another one. A times b to the power 4 times c to the power 7. B to the power 4 is out. A remains. C to the power 7. That means c remains. AC, the product of AC is less than 0. Now, I'm telling it to you, this are the two important properties that will make your time saving right start. So, just go back to this video once it is uploaded and please have this rule ready for you. Question says, if a to the power 5 and b to the power 4 is greater than 0, I know that is a is greater than 0. Simple. And ab is less than 0. Okay. Which of the following must be true? See, I already gave you the answer, a is greater than 0. I'm not telling that is the final answer because we have to see the multiple choices here. But again, that is one of the answer for sure. Now let's go ahead and apply the property, which says the square are important and even exponents are neglected and odd property remains. Let's try about this. A to the power 5, b to the power 4, a greater than 0. Option number 1, done. AB is less than 0. You can divide both the sides by a. B is less than 0. Option number 2 also works. Because when a is already less than 0, b has to be less than 0. Because their product is negative. When a is already greater than 0, b has to be negative. Now, what about a plus b greater than 0? Let's take this option. A greater than 0 is proved. B greater than less than 0 is already proved. A plus b, directly put the values now. A is equals to 2 because it is greater than 0. B is equals to minus 3 because it is less than 0. 2 minus 3 is minus 1, which is not greater than 0. So in this scenario, you would get it as not true. So the options are only first and second. Answer goes as D. This will save you a lot of time. Let's talk about the inclusive relationship. Now, this is a trickiest part of today's webinar. The inclusive relationship between a question's stem and the conditions. If there was a range of given in the question, and if that includes the range of the statement, then that particular statement will be your answer. In the jargons of the variable approach, I'll say if the range of the question includes the range of the condition, that condition becomes the answer. Always remember that question is a king and conditions are servants. So king will always include the servants. So let's talk about this. What happens if B is the answer? Question is X less than 0? So we have a range here and we need to see whether X is less than 0. Condition number 1 is X is less than 1. X is less than 1 does not include the range X is less than 0. So this is not sufficient. X is less than minus 1. It includes the range X is less than 0, which is a question, includes the range X is less than minus 1. Because X is less than 0 is from 0 to minus infinity. So your range is 0 to minus infinity and X is less than minus 1, it is included. That becomes your sufficient condition. So condition number 2 is sufficient. So answer would be B. Let's talk about in the case of A now. Is X less than 0? We have to verify the same for the given figure. 1 is less than X. That means X is greater than 1. This is satisfying the condition. Because your answer is no. 1 is less than X, that means X is less than 1. So is X less than 0? No. So that becomes your answer. Condition number 2 says minus 1 is less than X. That means X is greater than minus 1. That doesn't say that is X is less than 0 or not. It may not. Let's go on to the next. In the case of C as an answer, now we know that when the C would be the answer, the most easiest thing is to combine both the conditions. So now the question says, is X lying between minus 1 and 1? Or minus 1 is less than X, and which is X is less than 1, whether this range is true or not. Condition number 1 says X is less than 0. X is less than 0. It does not include the range, which is X is less than minus 1. So this will not include the left range. Condition number 2 will not include the right range. So we have to combine both the conditions here. And once we combine both the conditions, We get it as -1 is less than x, which is less than 1. So this is the basic application of, how do we combine the ranges. In the case of D as an answer, is 0 is less than x. Question is still the same. Is 0 less than x? 1 is less than x. So what does that mean? 1 is less than x and 0 is less than x. So that particular condition is includes the range 1 is less than x. 1 is less than x, which is less than 2. 1 is less than x is already proved. X is less than 2. That also includes into the given condition. So this would also be the sufficient answer. How about this? Is 0 is less than x? X is less than 1. So x is already greater than 0. X is less than 1. It's not into the inclusion. Doesn't follow. Condition 2, x is greater than -1. It may not be greater than 0. It may still be negative. So both of the condition is not included, and hence the answer is, for this, it will be E. So in this particular fashion, let's try solving this question. Is x plus 1 times x minus 2 is less than 0? Now always remember, we have two factors whose product is less than 0. So their sign will not be same. Let's apply the variable approach. And we would be applying properties, because we have -2 in the condition, we have x cubed, so we know that we'll be applying the square properties and the basic first fundamental concept also. So now x plus 1 and x minus 2, which is less than 0, they both will not have the same sign. So if x plus 1 is less than 0, then x minus 2 has to be greater than 0. So what we get here is x is less than -1 and x is greater than 2. So this would be a null set or an empty set, because there is no x that can satisfy being less than -1 and greater than 2 at the same time. The other possible consideration is x plus 1 is greater than 0. That means x is greater than -1, and x is less than 2. That means x lies between -1 and 2. So question is asking us, is x between -1 and 2? Condition number 1 says x cube is greater than 0. X cube is greater than 0. That means x is greater than 0, right? So if x is greater than 0, does that particular condition include the condition? The question is, x is between -1 and less than 2. X is greater than 0. That is not including this particular condition. So the condition number 1 is not true. If we say x minus 2 is less than 0, that means x is less than 2. Now my question is, -1 is less than x less than 2. So it still does not include x is less than -1. It says x is less than 2, but it does not include x is less than -1. So this again is not unique. If I combine both the conditions, which says x is greater than 0 and x is less than 2, then I get it as 0 is less than x, which is less than 2, which is combined and sufficient enough to answer. If we graph it on the number line, question says, is -1 and 2? Condition number 1 says 0. It's not completing the range. It's not a part of its range. Second one says whole 2, not sufficient again. Third one says 0 and 2. It's a part of its range. Because when you say 0, you don't know the end of the right hand side. When you say 2, you don't know the left hand side. But when you say 0 and 2, that's a range. And when we say range, there has to be highest and a lowest. Let's talk about what is a relationship between the functions and inequalities, and how does the graph changes with the time. So if we have a quadratic equation, if we have a linear equation, so if we have a polynomial, maybe cubical polynomial, then we always get it through whether a is greater than 0 or whether a is less than 0. So it says a is greater than 0 for y equals to ax plus b. Your quadratic ax square plus bx plus c shape looks like a U. And then you have a zigzag pattern for ax cube bx square plus cx plus d. But if a is less than 0, then you have a downward slope for the line. You have downward open quadratic curve or parabola. And then again, you have a zigzag that starts from the top and ends up at the bottom. So how do we understand this? So if we have y equals to ax plus b, which is a linear equation, if a is greater than 0, it will be increasing rightwards. But if it is less than 0, it will decrease rightwards. So this is a basic concept for the slope. Talking about the parabolic equation, which is more often seen into quadratic, if a is greater than 0, it's open upward. If it is less than 0, it is opening downward. If it's a y equals to ax cube, which is a cubical polynomial, if a is greater than 0, it's a zigzag path, but it starts from downward and it opens upward. For a less than 0, it would be starting from upward and then it will go to the downward part. Let's talk about this conditions now. We have x square minus 3x plus 2 less than 0. We know the factors are x minus 1 and x minus 2. So our range would be between 1 and 2. That is, 1 is less than x, which is less than 2. If I put y equals to x square minus 3x plus 2 greater than 0 or equals to 0, I get x equals to 1 or 2. So this is a condition that I put a equals to 1. That means it is greater than 0. Over here, a is 1, which is greater than 0. So I'm getting x equals to 1 or 2. If it is greater than 0, then x square minus 3x plus 2. The factors are same, x minus 1, x minus 2, but now they have been put to greater than 0. So they'll have both same sign. So you will always get the outward range. So either it is from 1 to left or 2 to right. There's nothing between 1 and 2. So first part was less than 0, you were getting between 1 and 2. Second was exact equals to 0, so you're getting at 1 and 2. And third one is from 1 to left and 2 to right. So this is a quadratic function that always goes up. Let's talk about this particular question. X cube minus 4x is less than 0. So if x is less than minus 2 or x is between 0 and 2, so you can often see here that when it is less than 0, when it is greater than 0, or when it is equals to 0, how does it change? So you get the exact point when it is equals to 0, you'll get the less points if it is in middle. And if it is greater than, then you always have the ranges from left to right and right to left. Let's talk about this particular question. If x square minus x minus 2 is less than 0, and x square minus 3x is greater than 0. Now we understand this is a binomial, so we would be definitely talking in terms of quadratic equation. For the standard equation of y equals to ax square plus bx plus c, we know if a is greater than 0, parabola will open upward. We know if a is less than 0, then parabola will open downwards. If that is the case, first fundamental concept has to be applied because we are dealing with inequalities. We can break or we can combine. So we need to know for both of the inequalities wherein one is less than 0 and another is greater than 0. So we'll check separately. X square minus x minus 2 is less than 0. That means y is less than 0. Now over here, a is 1. That means the parabola should be upward. Solving this, my value should lie between minus 1 and 2. So that means x is lying between minus 1 and 2. The second condition says, so this is how we solve this. This particular expression would be factorized at x plus 1 and x minus 2. Now x equals to minus 1, x equals to 2 when y equals to 0. So just put y equals to 0 to solve this. Now since the parabola is opening upward, As a is equals to 1, it has to be greater than 0. So they will not have same sign because it's completely less than 0. So parabola is opening upward. That is given by the coefficient of x square. The product of both the factors x plus 1, x minus 2 is less than 0. So they'll not have same sign. So if x plus 1 is less than 0 and x minus 2 is greater than 0, it becomes empty. So finally, we get through minus 1 is less than x, which is less than 2. Now let's talk about the second condition, which says x square minus 3x is already greater than 0. And over here, a is again 1, which is positive. So parabola opening upward, but it is greater than 0. That means the condition is x times x minus 3 is greater than 0. So my condition says that x times x minus 3 is greater than 0. They both will have the same sign. Now, the major mistake that a student does here is they take x is greater than 0 and x is greater than 3. That is it. That is the only condition they take. They forget to make a note of this, that this is a product of two factors which has to be greater than 0. So they don't consider these two factors to be negative, because the product of two negative numbers is also positive, which may change the answer. So now here, if x is greater than 0, x minus 3 also has to be greater than 0. So x is greater than 0 and x is greater than 3. So x is greater than 0 and x is greater than 3. X is greater than 3 has that range of x greater than 0. So your first one condition is x is greater than 3. If they both becomes negative, it says x is less than 0 and x is less than 3. So x is less than 0 will be the proper condition. So my answer would be x is less than 0. So overlapping, this is how the two particular ranges are getting overlapped. First one was minus 1, 0, 2. Second one is 3 and 0. So my answer lies between minus 1 to 0. What is the effect of the negative numbers when it comes to, this is also a type of a question that are, I mean, these are the favorite questions of the GMAT. A reciprocal will not always change the direction on inequality sign, but I have seen most of the students just in hurry apply the logic that they just change the sign. If a is already greater than b, then 1 upon a is less than 1 upon b is not true. If a is greater than b and b is already greater than 0, or if 0 is greater than a and a is greater than b, then 1 upon a less than 1 upon b will be true. So make sure then what it is. So don't learn the concept superficially. Always be careful of a square. If it is given that a is greater than b, you cannot apply the rule a square is greater than b square, because you don't know whether a and b are positive or a negative. So this is something which you can always remember and directly apply. You don't have to always plug in and check the values. If it is given that a is greater than b, which is greater than equals to 0, or we could say mod of a is greater than mod of b, or we could say a square is greater than b square, then yes, we can apply this rule that a square would be greater than b square. But if it says that 0 is greater than equals to a, which is greater than b, that means both are negative, then your inequality changes. That becomes a square is less than b square. So these three rules are the most, I would say, applied rules. And for this, students often don't they don't remember it and recall it. They always are in the habit of plugging the numbers, and that takes a lot of time. Let's talk about this. If a is less than b, they already said a is less than b, then which of the following must be true? Now we know that a is greater than b. 1 upon a or is less than 1 over b is not true. It is only true when we have 0 greater than a greater than b. And a plus minus x is something which we have been already applying. So the first option says 1 upon a is greater than 1 upon b. We are not aware about the sign of a and b, so we cannot say anything about this. So this is not true always, because they're asking must be true, not could be true. Second is a square is less than b square. Now the question here is already told, if a is less than b, a square would be less than b square? No, this condition cannot be true. Because if a is 1 and b is 3, a is less than b. 1 is square is less than 3 square. But if a happens to be minus 3 and b is still 1, it's still a is less than b, but the inequality doesn't satisfy. Option number 3 says that a minus b is less than 0, which is a is less than b. So your job is automatically done. So answer would be C. What is an absolute inequality? Now, before I talk about this, the next webinar that I would be conducting would be all about the absolute values. And I have enclosed some major concept of inequalities also. So don't miss on that as well. If x square is greater than equals to 0, then x square plus 1 will be also greater than 0. That means x square plus minus x plus 1 would be greater than 0. This is also one of the major concepts. See, every concept that I'm taking today is a Bible for the inequality that is applied in all questions for DS and PS inequalities. And this will save you a lot of time. So x square is greater than equals to 0 for all the values of x, because x square cannot be negative. If x square cannot be negative, if x square is already greater than 0, then x square plus 1 will always be 0, because the minimum value that x square can take is 0, and 0 plus 1 is always greater than 0. Doesn't matter that x is positive or negative, but if it's x square plus minus x plus 1, it will always hold for greater than 0. So let's talk about this question which says x to the power 4 minus 1 is less than 0. Then what is the range of x? Now we know there's three rules. X square is greater than equals to 0. X square plus 1 would be greater than equals to 0, would be greater than 0. And x square plus minus x plus 1 is greater than 0 for all x. So the rule is between an LL and GG. So if a is greater than 0 in this quadratic equation, which is ax square plus bx plus c is less than 0, it is in always in between. Always remember this fact. If your coefficient of x square is positive, that means parabola is opening upward. And if your quadratic expression, which is given in the question, is less than 0, your values would be in between. If your parabola is opening upward still, but if your expression is also greater than 0, your values would be LLGG, that is greater the greatest and lesser the less. So it's going from left to left and right to right. There is nothing in the between. We have this question, x to the power 4 minus 1 is less than 0. 1 to the power 4 is, this is how I can express it. That becomes x to the power 4 minus 1 to the power 4, which becomes x square whole square minus 1 square whole square. A square minus b square happens to be a minus b. So I factorize it as x square minus 1 times x square plus 1 is less than 0. Now, when they're less than 0, before getting into this fact that which one would be negative and positive, recall the concept that x square plus 1 would be always greater than 0. If x square plus 1 is always greater than 0, that means the other factor has to be negative because the product of two factor is less than 0. That means x square minus 1 is less than 0, which can be again factorized at x minus 1 and x plus 1 is less than 0. So the range would be between the roots of x minus 1 and x plus 1, which is minus 1 is less than x, which is less than 1. B is the correct answer. That's it. Let's talk about the continuous square root. This is one of the predominant question that has been often said, given so that, a student takes much of the time into it. One is the standard, always keep this. If you're taking continuous square root of a number, the value moves closer to 1 with every square root. Always remember this concept. See, the most important theory is square is important, question is the king, and 1 is the standard. So now how do we apply it? Let's see here. If x is greater than 1, then 1 over x would be less than 1, would be less than square root x, would be less than x, would be less than x square, would be less than x cube. I'm telling it to you, there are a lot of questions which are framed on this particular concept, and students often try putting a lot of values and they get trapped. or they waste their time. I'm not saying that they get the wrong answer, even if they get an accurate answer, but if it takes 4 or 5 minutes out of them, it's not a proper approach. If your x is lying between 1 and 0, then just reverse it. X cube would be less than x square, would be less than x, would be less than square root x, would be less than 1, would be less than 1 over x. So 0.9 is less than square root of zero point 0.9, which is less than 1, which is less than square root of 2, which is less than 2. Let's talk about this. X is greater than zero point 0.3. Which of the following options can be value of x? Now, x greater than 1, we know that, what is the rule. And if x is between 0 and 1, we know that what is the rule. So we know now that 0 would be less than 0.3, that would be less than 1. So 0.3 cube would be less than 0.3 squared, would be less than 0.3, would be less than a square root of 0.3, which is less than 1, which is less than 1 over 0.3, because our x is greater than 0.3. We are applying the second rule here because our x is lying between 0 and 1. So now square root of 0.3 is greater than 0.3. 1 is greater than 0.3. 1 over 0.3 is greater than 0.3. What is the option? We only have one option, which is a square root of 0.3. So our answer goes as 0.3. These are the two important rules. Kindly make a note of it after going through this video again. Let's talk about the ranges of values and how does the arithmetic operation affects it. So this is a common mistake. If -2 is less than a, which is less than -1, and 1 is less than b, which is less than 2, if you multiply this, we get -2 times 1, which is less than a times b, which is less than -1 times 2, or -2 is less than the product of ab. So product of ab is lying between -2 and -2. How is that possible? So in this scenario, we need to consider all the different values of the product of AB. This is also one of the most predominant question in GMAT. If your x is between -4 and 1 inclusive, and if your y is between -3 and 5 inclusive, and if the range of xy, the product of xy is A, and the range of x minus y is B, then what is the value of A minus B? There are a lot of calculations involved into it. We know that the range is always a maximum value minus the minimum value. So in this scenario, you need to understand that your minimum and your maximum value lies between x plus y, x minus y, xy, and x over y. Now, when it says that you need to find all the minimum values. Now, x is between -4 and 1, which is inclusive. Our expression is -4 is less than equals to x, which is less than equals to 1. And your y is between -3 and 5 inclusive. That expression becomes -3 is less than equals to y, which is less than equals to 5. Now let's talk about the different values of x, y. So it would be -4 times -3, -4 times 5, 1 times -3, and 1 times 5. Your minimum value would be -20, and your max. So it's not like you're multiplying left to left and right to right. It's all about left, 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 right. So you need to take in consideration all the four possible cases. So your minimum value here becomes -20 for xy, and maximum value becomes 12. Let's the range of xy. So you need to find the range of xy. So that is 12 minus of -20, which becomes 32. Now let's talk about the different values of x minus y. So that is -4 minus of -3, -4 minus 5, -4 plus 3. So -4 minus of -3 gives you -4 plus 3, which is -1. -4 minus 5 gives you -9. 1 minus of -3 gives you 4. and 1 minus 5 gives you minus 4. Your minimum value is minus 9, your maximum is 4. Your range becomes 4 minus of minus 9, which is 13. Now we have to find the difference between the ranges, which is 32 minus 13. That makes it 19. I'll welcome your thought on this. I'll definitely welcome your thought. You can write me back onto my personal email, which is puneet@mathrevolution.com regarding this. But I'm definitely recommending this today that you must know this unique tips to solve the inequalities in quick nick of time. If we still continue to put a conventional approach or putting in or plugging in values to do it, your accuracy would can be still maintained, but you will not be able to win over the time. And secondly, when you apply the variable approach, this is the place wherein you have to exactly apply it to see its proper application. If you wish to connect to me to talk in person about your preparation, your score raise, or anything, you are most welcome. You can definitely book a consultation call with me. The links are available on GMAT Club, also on our website, which is www.mathrevolution.com. We have updated our content in a much better way. So if you're looking for a solution, you could always see for this particular lessons. You can avail the trial pack, which is for 7 days. You have all the video lessons, all the topics, all the subtopics, and 1,500 practice question. If your exam is very much near and you're looking just to raise your score very in the quick fashion, you need to get through hold of some important tips, which is available in the shortcut program, which is there on our tab on demand. If you still have a time and you're looking for access of a complete package, you could often see those into all in one. If you are a newbie and have found it very difficult when it comes to math in your life, you can often avail one of our best expert for your tutoring service. Going ahead with this, I'll just say, access all the material. You can register with us and have the, best approaches learning through our free resources. And you cannot be satisfied with mid 40 now. This is for sure. If you have any inquiries, you can write on to either of this email for the particular concern. The next webinar would be all about the absolute value. This webinar would be soon uploaded today. Kindly go through every slide slowly. Make a note of it and then start applying the logics for yourself. With the same words, I wish you happy 2021. Let's welcome it together and keep doing your preparations great, good. And thank you so much for your patience and joining in today. You have a lovely night. Bye bye.